Problem 4, Part C, shows that the product of two imaginary numbers, -6 plus I and -6 minus I, can be a real number, 37. Number pairs of the form a plus bi and a minus bi are complex conjugates. The product of complex conjugates is a real number. Notice, a plus bi times a minus bi, this pair of complex conjugates, equals a squared minus bi squared. That's a squared minus b squared times I squared. Replacing I squared with -1, that's a squared minus b squared times -1, or a squared plus b squared, a real number. You can use complex conjugates to simplify quotients of complex numbers. Problem 5, dividing complex numbers. What is each quotient? Part A, 9 plus 12i over 3i. Note the quotient is written in fraction form, and we'll multiply this fraction by another fraction equal to 1, but 1 written in a way that accomplishes some work for us. We're going to write 1 as the complex conjugate of the denominator over the complex conjugate of the denominator. In this case, that's -3i over -3i. Now when we multiply our quotient by this fraction equal to 1, the multiplicative identity tells us we're not changing its value, only its appearance. Multiplying, we now get -27i minus 36i squared over -9i squared. Simplifying and substituting -1 for I squared, this becomes -27i minus 36 times -1 over -9 times -1. And that's 36 minus 27i over 9, which reduces to 4 minus 3i. Part B, 2 plus 3i over 1 minus 4i. Again, we'll multiply this fraction by 1, but 1 written as the complex conjugate of the denominator over the complex conjugate of the denominator. In this case, that's 1 plus 4i over 1 plus 4i, and multiply numerator times numerator and denominator times denominator. 2 plus 8i plus 3i plus 12i squared over 1 plus 4i minus 4i minus 16i squared. Substituting -1 for I squared, this is 2 plus 8i plus 3i plus 12 times -1 over 1 plus 4i minus 16 times -1, and that's -10 plus 11i over 17, or to write the complex number in standard form, -10 over 17, the real part, plus 11/17 I, the imaginary part. It's worth noting that multiplying the denominator by its complex conjugate eliminates the imaginary part from the denominator in both cases, allowing us to simplify the quotient to a single complex number. Your turn, Part A. What is the quotient 5 minus 2i over 3 plus 4i? Part B, what's the quotient 4 minus I over 6i? Part C, how about 8 minus 7i over 8 plus 7i?